So when you're doing the particle motion problems, you always want to start with what did they give me? And they can give you position, velocity, or acceleration. Usually they give you either position or velocity. Oh, and the back of this is blank because it's not too many problems. I want to put a little like lead in to this. So position for some reason is S for position. Then you have velocity and then you have acceleration. When I like put this together like this, it ends up helping people. I like to do it on the second day though, so I'm not like overloading you on the first day. But do you remember above sea level and below sea level? Do you remember the derivative graph matching thing? I bring that up a lot because that's what this is. Like this is a function, this is the derivative, and that's the second derivative. Where your position is increasing, that means its derivative is what? Positive. Good. And where your position is decreasing, your derivative, your velocity, is negative. Now, if that information is true from here to here, when you take a derivative, then it's going to be true from here to here. Are you following me? So increasing positive, decreasing negative. And in theory, every time you take a derivative, you could go on infinitely. We just don't go past the second derivative. The rate of change. I don't know what you'd call the one after the rate of change. I don't know. Anyway, we don't go any further. Also, example for units. Position would be something like feet. Velocity would be something like what? Feet per second. Acceleration would be something like feet per second squared or per second per second. Okay, so just like that helps a lot. So you can always look back at that. All right, so number one, what did they give us? That's like the question of the day. What did they give us? They gave us position. So it's what did they give us? What are they asking for? All right. For what values of time is the speed increasing? That is where velocity and acceleration, because you have to look at both. Speeding up, speed increasing, velocity and acceleration are what? Same sign. Speeding up, speed increasing. So this is sort of a complicated question. You have to find velocity and you have to find acceleration. We're going to make some number lines, which you did last year in pre-calc. So that won't be new. We're going to have to find where they are the same sign, either both positive or both negative. So first, let's get our velocity. Derivative of position. When you multiply this 3 down, the 3's are going to cancel. Convenient, huh? It's almost like it was planned that way. What are you going to get? 4t squared, good, minus 16t plus 12. Leave a little bit of a gap there so we can play around with that some more. Let's also go and get the acceleration because we're going to need it. You need them both. So what is the derivative of velocity? Yeah, 8t minus 16. Now we're going to need to do a little bit of algebra. What do all of these divide by? Like you want to be a good noticer. They all divide by 4. Let's just divide them all by 4. It's kind of like reducing a fraction. It'll make the numbers smaller for us. So it'll look like that. I just divided them all by 4. Why? Because I'm allowed, and it made the number smaller. So it's sort of like because I said so. Now let your instinct kick in. It's a trinomial. What does it like feel like you're going to do? Factor. Okay, you have instincts. Use them. That's the next thing we're going to do is factor that. It'll be 3 and 1. And then what symbols will we need? Yeah, they're both negative. Good. Now, let your instinct kick in here. What do these both divide by? 8. So if you divide by 8, you get t minus 2. And I'm going to give that a hug because I'm a nice person. I just want to give it a hug. So here's what I'm going to do. I'm going to make a number line for my velocity. And I'm going to make a number line for my acceleration. I'm going to start them both at 0 because we don't have negative times. And we're going to put where the changes will happen, and we'll put in our little plus and minus signs. All right. So looking at velocity, what would make each of these 0? 3 and 1. Okay, 1 comes before 3, so I'm going to put that first. Looking at acceleration, what would make this 0? 2. Do you see how I put the 2 in between the 1 and the 3? Okay, this is a number line. So let's pick test numbers. Can you give me a number between 0 and 1? 0.5, a half, right? If we plug a half into our velocity, You don't need to figure out what it actually is, just whether it's positive or negative. If you were me in pre-calc, I did like this. Okay, cool, head's nodding. So if you plug in a half minus 3, negative. A half minus 1, negative. A negative times a negative is positive. So that section is positive. Coming back to you. Give me a number between 0 and 3. 2, ready? 2 minus 3, negative. 2 minus 1, positive. A negative times a positive is negative. Now, what do you think the last section is probably going to, yeah, and you can pick a test number if you want, but I'm not here to waste your time, all right? Give me a number between 0 and 2. 1. Now, this time we're testing acceleration. 1 minus 2, negative. So this is negative, and then it's going to turn positive. Do you also remember me saying if nothing weird happened, and if something weird happens, you're going to know because you're going to be like, huh, that was weird. It's going to be negative and then turn positive. Do you remember that? Like,
Yeah, I remember.
okay, good. I taught it to you. All right, I'm going to draw in my little balloon strings. I call them balloons. If you weren't with me, I call those little balloon strings to separate it all. And now let's not forget what we were actually doing and what the point of all this was, because I was like, what on earth are we doing? Let's call all my pluses and minuses in here. We want where velocity and acceleration are the same sign. So let's look at the first section. Velocity is positive, acceleration is negative. Do I want that section? No. As a heads up, I'm about to color this in. Some of you were in my class that freaked out when I colored it in last year, so let's try to hold it together, right? Look at the second section, negative and negative. Oh my gosh, they're the same sign. I want that section, so I'm going to color it in. And then what other section do I want where these are the same sign? Yeah, the last one. So when you write your answer, we want from 1 to 2, union 3 to infinity. I don't love that there's an infinity there. That doesn't settle well with me. I get that time is going to go on. I sort of wish there was an ending point, but they didn't give us one, so we're going to have to just go with that. And if they asked you to justify, it would be because velocity and acceleration are the same sign there. Sometimes I write the justification first, because then it's like, then I don't have to worry about it after that. All right, 2 particles start at the origin. They're moving. Oh, from 0 to 10. Good. They gave us an interval there. What did they give us? Position. They gave us position. Are given by these 2 things. They called them x1 and x2. For how many values of time do they have the same velocity? Well, we're going to have to get the velocity of the first one and the velocity of the second one. And this would be a calculator problem. So while we're writing that down, I'm going to pull up my Desmos here so I can type this in. What is your derivative for this first one? Cosine of t, good. Now you do need a rule for this one. Which rule do you need? Chain rule, good. E is itself, so it's going to be e to the negative 2t. And then you're going to chain on the derivative of negative 2t, which is negative 2. And then is there anything else there, or are we done? That's it. Okay, so here's what I'm going to do. I'm going to share my screen. Your default setting is radians, so you don't need to change it. We're going to do cosine. Now, it will only work for x, so don't type t in here. So I type cosine of x. Do you see that?
Yeah.
Okay. And then I'm going to put that negative 2 out front for the other one. Negative 2e to the negative 2x. I need to change my window, so I'm going to come over here and hit the little wrench button. And what was our window? All right, so do you see where it says x-axis here? I hope the cursor shows up on the recording. I'm going to make that 0 to 10. See what I did there? Now, it says for how many values of time are these equal? So we're just going to count the intersections. Now, the blue one, the exponential one, it looks like it disappears, but do you understand that it keeps on going? It's like leveling off at that asymptote. So we've got 1, 2, 3. So 3 is your answer. There are 3 values of time where those are equal. So that would probably be more a multiple choice question, but not really. I would maybe write 3 values where same velocity, but no, they kind of just have to accept that because that's how they worded the question. So they kind of just have to accept that. Now, this one, they throw a different vocabulary word at you. It says displacement. So you want to use your context clues. It says in feet, just feet. So is that position, velocity, or acceleration? That's position. So that's another word we can use for that. So use the context clues. If it said feet per second, that would be a velocity, you know, for example. I'm also going to rewrite this. For some reason, this like throws everybody off. I kind of get it. I'm going to write it as 1/6t cubed. That makes like a world of difference just with understanding what's going on. Do you see what I'm saying? Like one way looks more confusing than the other, so I would just rewrite it. Now this says find the average velocity, and this says find the instantaneous velocity. What do you think? Which one is just regular old algebra 1 slope? Yeah, A, average rate of change. That is going to be regular old slope. We're going to get 2 points and we're going to slope them. Instantaneous rate of change, instantaneous velocity is where you have to actually do some calculus. So this one's algebra, this one's calculus. So it says over the time period 0 to 1 second. So we want to plug in 0, we want to plug in 1 and just see what we get. Don't overthink this. This is a really simple question. If you plug in 0 for time, what do you get? 0. And if you plug in 1, you get 1/6. It's really simple because one of the points is 0, 0, but if you go to do your slope, it'll look like that. And so what does that all boil down to? Yeah, like literally just 1/6. And then I just want some units. What would our units be? Feet per second. Is it feet or meters that physics people use? Is it meters? Physics uses meters? Okay. Oh, I'm so sorry. Because in calculus, we usually use feet. Sometimes they'll throw meters or something else weird in there, but it's usually feet. I'm sorry. If you're a physics person, you have to really like switch gears to just make sure you read is all it is. Right? So derivative, we're going to find our velocity. We're going to find our velocity. So that's a derivative. So you would bring down the 3. That would give you 3/6, which is 1/2 t squared. And then we would plug in whatever they told us, which is 1. So 1/2 feet per second. So again, average is over an interval. Do you remember Alice went for a walk? I bring up Alice and her walk all the time because that's, you know, where I introduced the topic to you. So over an interval is average at one particular moment is instantaneous. Algebra, calculus. Yeah. I'm going to do one more and then do a break if you want to just hold on through number 4. Number 4, a particle is moving. What did they give us? Velocity. I don't like to read to you because that teaches you to not read, okay? Velocity is given by t cosine t. For what values, and they give us an interval 0 to 5, is the particle moving upward? Do you remember me saying in the context of the problem that would be forwards or upwards or to the right? Like those all mean the same thing. So that's where velocity is what? Positive. Interpreting what they're asking is like half the battle, right? So where velocity is positive. They gave us velocity. We just need to know where that's positive. We're going to make some number lines. So I'm going to make a number line for t and a number line for cosine of t. And I'm going to cap it 0 to 5 because they said so. So just t is going to be the easiest thing in the world. If you plug in a number between 0 and 5 to just t, like, is that going to be positive or negative? Yeah, positive. They're all above 0. So it's sort of, you don't even almost need that number line because it's positive all the time. Now, this is where some unit circle is going to come in. So we're going to go from 0 to pi over 2. Where's our next stop on the unit circle where this could change? Pi. And then the next one. Now I stopped there. Why? Why didn't I go to 2 pi or then further than that? Because you can go around the circle, around and around and around. Like, why didn't I put 2 pi in here? What is pi roughly? Let's round it to 3. I can't put 2 pi here because what's 2 times 3? And why is that a problem? It would be off the interval. Do you get that it would be over here? So I didn't go above 5 is what happened, okay? I like to think of this visually. Where does the cosine wave start? 1, good. So above sea level. So this first part's positive. And then it goes below all the way to 3 pi over 2. And then it goes above. It's a wave. The other thing you can do is think about your unit circle. Visualize this with me. Visualize the circle. Can you see it in your imagination? Cosine is the x value. Are you seeing that, like, when you go to the left, that's where the negative part is? However your brain does it. I forgot what they were asking at this point. What do we want? Yeah. And that's the other reason I write that, because I am a distractible person. And if I write the justification to start with, then I remember what I'm doing. All right. So where is our velocity positive? On which intervals here? The first one. So we want 0 to pi over 2. And then where else? The last one. And if it asked for a justification, you would say because velocity is positive there. If you write the justification first, that kind of calms you down. It reminds you what on earth you're doing if you're like me and you're like, ooh, a squirrel, you know, so you write that first. And then this one's simple. It says, write an expression for acceleration. All right, well, they gave us velocity. How do you get from velocity to acceleration? Yeah, derivative. Now, what rule do you need for that one? Product. T is the first thing. Cosine is the second thing. So how does your product rule start? We didn't forget it already, right? The first thing, T. Good. What's your derivative of cosine? Negative sine. Perfect. Plus the second thing. I don't like when it's cosine of T. It looks like cost. And then derivative of the first thing. Derivative of just T is 1. If you don't want to write the 1 at this point, I will let that slide. All right, so read number 5. What did they give us? So is that position, velocity? Why is that position good? It says feet. You want to look at your feet per second or feet per second squared. That's your clue. All right. Find the velocity after 2 seconds. What are we going to do? Find the derivative. Perfect. And then, like, beautiful. Again, interpreting what on earth you're supposed to do is like most of the battle. If you can figure that out, then usually you're okay. All right. So what is, and then usually the derivative isn't too bad. What is our derivative of this guy?
3t squared.
All right. 3t squared plus 4t. And then we're going to plug in 2. So that from there, that's not even algebra. That's arithmetic, right? 2 squared is 4 times 3 is 12 plus 8 is 20. Units would be feet per second. Good job. B is how long does it take? So our answer will be something seconds. How long does it take for the velocity to reach 4 feet per second? So you're not going to plug in 4 to the velocity. Good, perfect. Now that is going to involve some algebra. You're going to take your velocity and set it equal to 4. What do I call this with this? Evacuate, evacuate, evacuate. It has to equal 0. So you're going to slide that 4 over so that it all equals 0. If you aren't sure what to do, evacuate. And then what? I heard somebody whisper back there. Factor, good. So it's going to split 3t and 1t. 4. 2 and 2, I think, is going to end up being right. If you try 4 and 1, it doesn't work. You just try something else. It's called guess and check, right? So the outsides give you 6t. I want that one to be positive. 3 times 2 is 6. 6 minus 2 gives you 4 in the middle. So what do you get as your first answer here? So 2/3 seconds. Now this one comes out to -2, so I'm going to get rid of it. Why? Time is not negative, right? We don't have untime. So 2/3 seconds. What? You don't have imaginary time. We don't have negative time. So sure. All right. Karen is riding her bicycle. Karen with a C is riding her bicycle along a straight road from home to school. Before we even read any more, well, actually, first, what did they give us? Because I have to know what they gave us. Did they give us position, velocity, or acceleration? Velocity. Okay. Let's see what's going on. Right here, velocity is positive, above sea level. What does that mean Karen did? She rode away from home. All right. Now this part is negative. That means she rode back home. What happened here? She's at home chilling. All right. And then for all this positive part, she went away from, oh, I think school is where she's going. But anyway, yeah, home to school. So hopefully she went to school and not McDonald's. All right. But we'll see what happens. All right. Find the acceleration of Karen's bicycle at time 7.5, indicate units of measure. If you aren't sure what to do, let's start with the units of measure. Her velocity is in what? Find it in there somewhere. Well, their minutes is the time. That's true. Miles per minute. So what are going to be our units of measure for an acceleration? Miles per minute squared. Now, I don't have an actual equation. I can't take a derivative because I don't have a function to take a derivative of. So we're going to fall back on derivative means slope. So at 7.5 is what they told us, which is right here. The common mistake is people say -1, and I totally get why that happens. But it's not -1, it's actually -0.1. Why is it -0.1? Yeah, it's scaled by tenths, all right? So just be careful. It's not hard, but it's really easy to miss that. And if you write -1, then it's wrong. All right. Shortly after leaving home, Karen with a C realizes that her calculus homework is at home, and she returns to get it. When did she start to go back home? At time when? We talked through it already. Time 2 minutes. Why? Because they do want us to justify. So let me speak to that because this happens all the time. If you say it, they will not give it to you. Because does it mean position, velocity, or acceleration? You have to cite the correct one. So at time 2, no, position, velocity, or acceleration. At time 2 minutes is correct. Why is that when she started going home, when she turned around? Velocity changes from positive to negative there. Okay, time 2 minutes because, and you're allowed to abbreviate, velocity changes from positive to negative there. She was going away from home, that's positive, and then she turned around and is going back towards home, that's negative. And then at 4 to 5, that's when she was home getting her homework, and then she left and went to school, hopefully. She forgot her calculus homework. She had to go back and get it. All right, I put all of this on here in case you're interested in how gravity works. But we only do the math part of the physics in this room. So I wrote it on there and you're welcome to read it. But these are your gravity coefficients for gravity pulling you down if you're in feet or meters. If you've taken physics, these should look familiar to you. Yes? Negative because you're being pulled downwards by gravity. Suppose a ball is dropped from a window 20 feet above the ground. What were we given? Position, velocity, or acceleration? That's position is given by that. We've got feet, we've got seconds. All right. Find the height of the ball after 1 second. What are we going to do? Plug in 1. Are we even going to take a derivative? Nope. We just want the height at time 1. If you plug in 1 to that, what do you get? For what? Four feet. Did it hit the ground yet? No, still 4 feet above the ground. Find the velocity after 1 second. What are we going to do? Derivative and then plug in 1. So what is your derivative of this guy? Negative 32t. That's why this is negative 32. Okay. I know, isn't that crazy? And then if you plug in 1, negative 32 what? Feet per second. The units are super important. And if you really know those units and get a handle on which one means what, it helps you when you're reading the problem to interpret what on earth they gave you and what on earth they want. You can use the units to help you. All right, when, so there should be a time, when will the ball hit the ground? What are we going to do? Which one are we going to set equal to 0? And what do we call that? Position. We're going to set position equal to 0. If the ball is on the ground, its position is 0. And then we're going to do some algebra. So what would you do to both sides? Minus 20. Divide by negative 16. So the negatives are going to cancel. 20/16. Gosh, what is that going to reduce to? 5/4. And then what's our last step? Yeah, square root. You square root the numerator, you square root the denominator. So the square root of 5 is square root of 5. Square root of 4 is 2. And the units are seconds, because it is a time. Now there's actually another part to that part. What is the other question? That's the time when it hits the ground. Now speed is very slightly different from velocity. Velocity is directional. It can be positive or negative. Speed is always what? Positive. So what you're going to do is plug this into velocity, but whatever you get, just absolute value it. Just make it positive. So if you plug square root of 5 over 2 into your velocity, it's going to look like this. You just won't do the negative. Like, we're going to absolute value it. Like, if you want to even just go like that, like throw absolute values around it, you're just going to turn it positive because it said speed instead of velocity. So whoever said 16, you're correct. 16 square root of 5, what? Speed? Well, but it's not miles per hour. Feet per second. But I knew what you meant. Like, I always think miles per hour too, because we spend lots of our time in a car. In a car. Yeah, go ahead. Yes. If you want to like visualize what's going on here, remember, a ball got dropped from a window 20 feet above the ground. So like somebody dropped it and it's moving downwards. So it has negative velocity. Oh, it has negative velocity and negative acceleration. So it is doing what? Speeding up, increasing speed in the negative direction. Because gravity's pulling it down. That's fine.
When does it go from like feet per second squared?
When you get to an acceleration, it's a rate of change. All right, last one. A ball is thrown upwards from the hand of a player. So imagine a baseball player throwing a ball. It starts out at a height of 2 meters. That's the initial height. That's why this says +2. Initial speed is 5 meters per second. That's the 5 there. This is your acceleration. I mean, I explained all that up here, but you're going to be given an equation. What is the speed of the ball after 1 second? What are we going to do? We need velocity, so we need the derivative. And then we're going to plug in 1, but what? We'll absolute value it because it says speed. All right. So what is our velocity? If you bring this 2 down, that would be negative 9.8 t plus 5. If you're like, how'd she do that in her head? What I do is I get rid of the decimal point and then I do the problem and then I put it back. So I made it 49. If you double 49, 98, and then I just put the decimal point back. Okay. So we're going to plug in 1 and then we will just absolute value it. So if you plug in 1, what would that be? Negative 4.8. So our speed is positive 4.8. Ooh, what are the units for this one? Because it's something different. Meters per second.
S.
Yep. All right, when, so this should be a time, is the ball 3 meters above the ground? What are we going to do? Perfect. Position equals 3. You're going to take this position equation and make it equal 3. Hold on a second, because there was another. Okay. You can evacuate that if you want, but that isn't going to factor. So this would be a calculator problem. All right, now I had changed the window around for the last thing that we did. Can you look over here? Do you see this little button with a house, the home button? If you hit that, it puts 0 back in the center for you. So, you know, all right, so I'm going to type in negative 4.9. Now you have to do x. It won't work for t. X squared plus 5x plus 2. Now for the other one, you can't just type the number 3. Nothing will show up. You actually have to type y equals 3. And then, do you see how it showed up there? You guys are so lucky you have Desmos. This is so complicated in the TI calculators. I love that you guys have this. I'm just going to zoom in on it. How many answers does it look like we've got? 2. Why are there 2 answers for when the height of the ball is 3 meters off the ground? Goes up through 3 feet, comes back down. Good. We have common sense. How many decimal points do we need here for our answers? 3. So you're going to write on your paper, and I'm sorry, I can't have my paper and the calculator up there at the same time. 0.273 seconds and 0.747 seconds. And I will go back to my paper so you can see that. But there's 2 answers. Goes up, goes through 3 feet, goes higher than that, and then hits 3 feet on the way back down. Yeah.
Why do we not set it equal to 3 with the velocity?
So that would be when the velocity is 3 meters per second. We just wanted the position of the ball to be 3 meters off the ground. That didn't involve a rate of change or how fast it was going. It was just where is the ball?
The ask the velocity.
Yeah, you would put the derivative equal to 3. Now this one says, when does the ball hit the ground? So we're going to take that position equation and make it equal what? 0. Again, and that already is evacuated, but that's not going to factor. That's not a problem you would do by hand. It's a calculator question, all right? But, hey, Ms. Cole, I could just get the answer from Desmos. Why do I have to write this? Because they make that worth a point on the AP exam. Just take the easy point and write it out. Position equals 0. Just write it. You get a point for that, okay? So let me share my screen. I already have it typed in. Where am I going to click?
0.
Yeah, at 0, right there. 3 decimal points. 1.327 seconds. This last one we're going to do without a calculator because we can. If you can do something without a calculator, you should try to. When is the ball at its highest point? Okay, come with me on this thought journey because they do ask you to do this without a calculator sometimes. The ball goes up and comes back down. For that one moment in time, what is your derivative? Do you see critical point? Oh, I should have asked, what are those called? Critical points. So you're going to take your velocity and set it equal to 0. Velocity equals 0. On the AP exam, a lot of times you will get a point for writing this. Always write down whatever your thoughts are because a lot of times you get a point for that. All right, so it's going to be, we already did it. It's up here. Negative 9.8t plus 5 equals 0. And then you're just going to solve that. So negatives cancel, which is good because we don't have negative time. 5 over 9.8 seconds, whatever that is.